I think we can start. Hello everyone, and thank you all for joining me here today. My name is Dejan, I'm very happy to be here, and today I'll talk about building a weather agent on Android with Koog. Before I get into it, a bit about me. So I'm doing Android development for over 8 years now. I'm based in Zagreb, Croatia, and I'm focused on building real-world products for clients and leading mobile teams. During this time, I've been lucky to work on large projects that have reached millions of users, and outside of my day job, I also worked on a couple of Android book projects and some tutorials, and I also given talks at international tech conferences such as droidcon. And today, I'm here to talk about AI agents in Kotlin. So before we get into creating our own agent, let's first understand what agents are. So what is an AI agent? An AI agent is basically a computer program that, instead of having a fixed set of rules, uses LLM as its brain. So LLM helps it think through problems and reach a goal. So agent can also call so it's not just like chatting with the LLM, where you only get a text back. Agent can actually go out and complete some real tasks for you. For example, they can call some tools, which are usually some APIs or functions, but it can be whatever. Agents can, send an email, check your calendar, and so on. And agents works in steps. So agent first thinks about doing something, then it checks if it worked, then it does that step, and it finally checks if it worked. So similar how we do things in real life. So what's the difference between an LLM and an agent? So a plain LLM is like texting a friend. So you send a message and you get a reply back, and that's it. An agent is more like a personal assistant that can go out and do things for you. So as I already said, sending emails, making phone calls, checking your calendar, whatever. Another way to think about agents is like a delivery driver with a GPS. So you give the driver the address, and that's the final goal. Then the driver uses some tools. For example, it can use GPS to plan the route, it uses a car to drive, or they can even call you if they can't find the right place. So they don't just tell you where your package is, they actually deliver it to you. So they complete a task for you. So you should use an agent when your task needs real actions. Every agent consists of a couple of parts. So each agent starts with a clear goal. So that's what the agent is trying to achieve. Then the agent follows some rules. So we are the ones that set these rules to the agent. So you can think of these rules as a short system prompts. So for example, this is where we can specify to the agent on how detailed we want the answers to be or what tone should be used. And then agent also has some tools available. These tools are some APIs or functions usually, but it can be anything. So agent can only use the tools that we give to it, nothing more. And finally, we set some limits to the agent. For example, how many steps it can take or how much time it can use before stopping. So the general loop of an agent is pretty simple. So first the agent thinks about doing something, and then it does that step. So that step can be calling a tool, or it can return directly a text message. After doing that step, it checks if it worked. So it checks the results, and it checks if the goal has been met. And if the goal is not met, it keeps repeating this cycle until either the goal is met or the limit, like step count, has been hit. So when should you use an AI agent? You should use an agent when your task requires some real actions, like calling some APIs or communicating with some external components, or if your task requires picking between multiple options. You should also use an agent if the user's request is vague or open-ended. So the main advantage of agent here is its iteration capabilities. Also, if your task has many small steps or branching paths, it's also a good indicator that the agent might be the right fit. On the other hand, if all you need is like one fixed API call, like getting some data from API, you don't need an agent for that. Also, if your flow is strict and rule-based, a plain function or a script is usually enough. You also need an agent for that either. And finally, if your task does not need any reasoning work, it's also a good indicator that you don't need an agent. So agent in that case will only add overhead without any real benefit. Now, agents are not perfect. Agents can sometimes guess wrong, or they can call tools in the wrong way. And each tool call adds cost and latency. So the more steps the agent takes, the slower and more expensive it becomes. So for safety reasons, we only give agents the tools that it really needs, nothing more. And also, for safety reasons, we keep the randomness to low. This can be controlled by the temperature setting, and we also set some step limits to the agent, and we check inputs and outputs to avoid any surprises or unexpected results. Cool. Now that you understand what agents are, let's get into creating our first AI agent with Koog. So first, what is Koog? Koog is a new open source framework from JetBrains for building AI agents in Kotlin. So Koog lets you build systems that can reason, act, and use tools. Koog is multi-platform. So this means that your agents can run on JVM, Android, JavaScript, WebAssembly, even iOS. So basically, wherever Kotlin runs, Koog runs as well. And Koog also handles a lot of the lower level stuff for you. So for example, you don't need to worry about raw LLM API calls, but you can focus on your agent logic instead. So what are we going to build today? For today's demo, we're gonna build a simple Android application with a weather agent. So the idea is that you can ask any weather-related question to the agent, and you will get a reply. So we are starting from scratch here. Our app currently only contains the UI layer and API layer that talks to the AccuWeather API. So we're gonna use AccuWeather to fetch live weather information. For now, there is no Koog code inside of this app yet. So from here, we're gonna add Koog to our project, and we're gonna start creating our agent step by step and see how it all comes together. So first step is to add Koog to the project. Koog comes as a bunch of different packages, and here we are only adding Koog agents dependency. So Koog agents is the main module for agent functionality. So it provides the functionality for creating agents, running prompts, managing tools, and so on. And you also need to make sure that you have Maven Central in the list of repositories, and of course that you specify the Koog version. Once we have added Koog dependency, we can start creating our first AI agent. To create an AI agent, we need to create an instance of the AI agent class. So AI agent class in Koog represents, well, an AI agent. So it gives you the functionality to run prompts, manage tools, and so on. And Koog provides us with this convenient builder function that makes it really easy to create an AI agent instance with a string input and string output. So we're going to use this function to create our agent, and we need to pass in three things here: executor, system prompt, and LLM model. So let's take a look into each of these and understand what they are. So we're going to start with creating a model. LLM model class in Koog represents large language model with a specific provider and its capabilities. So we're going to use OpenAI as our model provider, and we need to specify which model we are using, which in our case is going to be GPT-4o. Now, Koog doesn't only work with OpenAI, but it also supports other most popular LLM providers such as Google, Anthropic, and so on. And of course, we pass our model to the AI agent builder. Next thing that we are going to create is an executor. So you can think of an executor as a higher level component that adds extra features to the LLM client. An executor can also manage multiple LLM clients, which is useful if our app talks with multiple LLM providers. In our case, we are only going to use OpenAI, so we can just create a simple OpenAI executor. And this is also where we need to pass the API key for our provider. So this is the common question that I see online. Is Koog free? So Koog is free and it's actually open source, but you still need to pay for the LLM provider that you're using. And the third thing that we are going to pass to our builder function is a system prompt. So system prompt is like a system level context for the agent. So you can use this prompt to give some detailed instructions to the agent on how it should behave. By default, this is just an empty string. So we are telling it here, hey, you're a helpful weather assistant. Please provide accurate and concise weather information based on user queries. This is where we set the tone and the style of agent's replies. And that's it. We have created our first AI agent. So we can run it now to see if it works. To run the agent, we can call agent.run and we pass in the query. And we see the same thing happening in the app on the right side. So we are asking the agent, what's the weather in London? And we get some reply from the agent. The reply that we get is that agent is basically saying that it doesn't have real-time capabilities and that it cannot check for weather. So this is expected. LLM models do not have live weather information or any other live information. LLM models are trained on historical data and they also cannot fetch weather data on their own. So what we have for now is AI agent that only talks to the LLM model. So next step is to add some tools to the agent so that it can actually fetch weather data and that it can do more than just talk. But before we start adding tools, let's just quickly take a look into what types of agents do we have in Koog. So first we have single run agents. Single run agents are the simplest. They take one input and produce a result. And that's pretty much it. And this is the type of agent that we are going to build today. And then we have functional agents. Functional agents allow you to define multiple step logic with Kotlin lambdas, and we also have workflow agents which handle more complex flows using strategy graphs. So functional agents and workflow agents are a bit more advanced and they are out of the scope of today's talk. Cool. So we have created our first AI agent. Let's now add tools to the agent so that we can fetch live weather data and that our agent can do more than just generate text. So first, what is a tool in Koog? A tool is basically a component that the agent can call to do something. Tools give agents access to external capabilities or resources like APIs, databases, system functions, calendar, whatever. In simple terms, tools let agents do real work, not just generate text. So without tools, an agent is just a chat box. But with tools, an agent can actually complete some real tasks for you. We have a couple of tool types in Koog. So first we have built-in tools. Built-in tools are already part of the framework and they handle some common scenarios such as interaction and conversation flow. And then we have annotation-based tools. Annotation-based tools let you expose existing functions as tools using just a tool annotation. So this is super simple and great for quick use cases. And finally, we have class-based tools. Class-based tools give you full control and allow you to implement a custom logic inside of your tool class. So you would use class-based tools for more advanced cases. Now, before we start creating our tools, let's first take a look into how the AccuWeather API that we are going to use to fetch weather data works. So to fetch weather data using AccuWeather API, you need to get the key for the specific location that you are fetching the forecast for. To get the key, we're going to use the search locations function. So search locations function will return a list of locations along with the keys for these locations, but based on the query string that we pass. And once we have a key for that location, we can call fetch forecast and pass in that location to get the forecast for the location that we want. So in our case, we are just fetching 5-day forecast. So we're going to build two tools, one for searching the locations and one for fetching the 5-day forecast for the given location. So we will start by turning our search locations function into a tool by just annotating it with tool annotation. So annotating this function with tool annotation will expose this function to the model as something it can call, so as the available tool. And you can notice that we are also using LLM description annotation here. So we can use this LLM description annotation to give some more information and details to the model about our function so that the model can better understand what this function does, what the parameter means, and how to use it. And now we're going to do the same for the fetch 5-day forecast function. So again, we annotate this function with a tool annotation to make it available to the agent as available tool, and we also annotate it with LLM description annotation, and we add some extra details about the function and the parameter. So we have two tools now, one for searching the locations and one for fetching the 5-day forecast for the location. Important thing to mention here is that all of the tool functions, all of the parameters and return types of tool functions need to be serializable so that Koog can send them to the model and deserialize the response. Since we have multiple tools, we can group them into a tool set. To do that, we are simply creating a new class, which we called Weather Forecast Tool, which implements toolset interface. Toolset interface basically just marks this class as a container for tools. So all of the functions inside of this class that are annotated with tool annotation will be available to the model as an available tool. And now that we have created our tools, last step is to add these tools to the agent so that the agent can know about them. To do that, first we need to create a tool registry. Tool registry is like a central place where we register all of the tools that the agent has available. In our case, the only thing we are registering here is the Weather Forecast Tool class instance. And of course, we need to pass the tool registry to the AI agent builder function. So now, when we run our agent again, our agent will know about the tools that we have created, and it can call them whenever it finds appropriate. So let's run our application now when the agent has the tools that we have created. So we're going to start by asking the agent the same question. We're going to ask again, what's the weather in London? And this time we get a response from the agent, but it's different. This time, so now when we send this question to the agent and when the agent has tools available, the agent is smart enough to know that first it needs to search for the locations that match the London query. So first it does that. However, search locations function returns multiple results. So apparently there are multiple Londons, London UK, London Canada, and so on. And the agent asks us to clarify which London are we referring to. Now remember, what we are building here today is a single run agent. So single run agents do not keep a chat loop alive. So single run agents cannot handle clarifying questions within a single run. So if we wanted to support that, we would have two options. First one would be to use a different predefined strategy, like a chat agent strategy. We're going to talk about strategies a bit later. And the second option would be to implement a custom logic to check if the agent asked a clarifying question, and if so, we would then run the agent again with the same prompt, but we would also include the response from the user. However, that's out of the scope of today's talk, so we're just gonna ask something more specific. We're just gonna ask, what's the weather in London, UK? So this time, the agent knows which London we are talking about. It calls our tools. So it first calls search location tool to get the key for the London, UK, and then it calls fetch 5-day forecast tool to fetch the forecast for the London, UK. And this time, the agent returns the forecast for London. However, this is just an example. We don't need to ask for the forecast directly. So in the third case, let's ask something more open-ended. In the third case, we're asking, hey, I'm traveling to London, how should I pack? So again, the agent is smart enough here to know that in order to give you an advice on how to pack, it first needs to fetch the forecast for London. So it uses the available tools, it fetches the forecast for London, it reasons over the data, and it gives you an advice on how to pack. So to understand better how all this works, let's track the request and response from the LLM by using an event handler. So Koog lets you monitor what's happening inside of your agent using an event handler. Event handlers are basically a way to hook into different stages of the agent's lifecycle, mostly for debugging and testing purposes. Event handlers also manage the lifecycle of agents' operations, let you react to errors, and let you track which tools are being called and what results do they return. So event handlers are super useful for visibility and for debugging reasons. To install an event handler, we can use the install features lambda, which is the last parameter of the AI agent builder function that we used earlier. Normally, you would just call install and pass in the event handler. However, Koog provides us with this convenient handle events extension function. So we're going to use this extension function to handle a couple of events. We're going to handle two events, actually. We're going to handle on before LLM call and on after LLM call. Before the call, we just print out the messages and the available tools that the agent has. And on after LLM call, we are just going to print the response from the LLM. So let's run our agent now, and let's see what do we get in logs. So these are the logs that we get. First request to the LLM is the user asking what's the weather in London. So under the messages section, we see that there are two messages. First, there is a system message where we set some context to the agent, and the second message is the user's prompt. Under the tools section, we see that our agent has two available tools. So these are the tools that we have created earlier. And the response from the first LLM request is not a text, but it's actually a tool call. So for the first request, the model has decided to call search locations tool with a London query. And then we have a second request to the LLM. For the second request, messages stay the same, but now they also include the search results from the previous step. And tools are still the same. Response from the second LLM request is again a tool call, but this time the model decides to call a different tool. This time it calls fetch 5-day forecast tool with a location key. And finally, we have a third response from the LLM. This time we get a regular assistant text message, which basically indicates that the agent has reached its goal and it stops executing. So it returns the actual forecast for London, which is what we were looking for, and once it does that, it stops with the execution. So step by step, we can literally see how the agent thinks, plans, and acts. To recap, let's just briefly take a look into how a general flow of a basic agent with tool call works. So first, user sends a prompt to the agent. Then the agent can resend that prompt to the LLM, or it can add some additional context to it. Then LLM returns a response. That response can either be a text message or a tool call. If it's a tool call, an agent invokes that tool and gets the tool call results from the environment. It then passes these results back to the LLM. And this loop keeps repeating until the LLM decides that it will not call any more tools and that it has reached the final answer. And once the final answer has been reached, the agent just returns that answer to the user and it stops executing. Cool. So now we have our agent that can call tools and that can fetch live weather data. So let's now take a look into how we can customize the agent behavior. This is where strategies come in. So what is an agent strategy? Basically, a strategy defines how an agent executes its workflow. So it's not just one call to the LLM and that's it. It's the strategy what defines the agent's full workflow. So how the agent thinks, how the agent calls tools, how it processes results, and when it stops. A strategy is represented as a directed graph of nodes and edges. So nodes represent steps in the workflow, and edges represent connections between these steps. So strategy is what turns a simple input LLM output flow into a smarter workflow with decision making. Each strategy consists of a couple of key components. So first we have nodes. Nodes are like individual steps or tasks in the workflow, so like a single unit of work. That can be, for example, an LLM call or execute tool call. Then we have edges. Edges define connections between the nodes. So edges define how the flow will move from one node to another. And then we have conditions. Conditions control when an edge is taken. So for example, we can decide to move to one edge if the LLM returns a tool call, or we can go to a different edge if the LLM returns a regular assistant text message. And finally, we have start and finish nodes. So these nodes define where the strategy begins and ends. So these are like entry and exit points into your agent. So each agent starts at node start and finishes at node finish. Now Koog already comes with a couple of predefined strategies, so you don't always need to create your own strategy. So first we have single run strategies. Single run strategies are the simplest. They take one input, they may or may not call tools, and they return a result. And single run strategies are being used by default. And then we have chat agent strategy. Chat agent strategy handles conversation. It's built for conversations, basically. So it handles the chat messages and it can call tools in between. And finally, we have React strategy. React strategy alternates between reasoning and acting, and it keeps repeating that until it's done. So when should you use a custom strategy? Well, you should use a custom strategy if the predefined strategies are not enough for your use case. For example, if your flow depends on tool call results, if you have loops inside of your flow, or if you need to run multiple tools in parallel. You can also use custom strategies if you need more control over your memory, error handling, or tracing. If you do need a custom strategy, here's how you can build one. So to build a custom strategy, Koog provides you with this strategy DSL builder that you can use that basically creates a strategy for you. So we are going to use this strategy to create our custom strategy just for demonstration purposes. When using this strategy builder, we need to specify the input and output types. In our case, both are strings, and we also need to give a name to our strategy. Next, we need to define the nodes of our strategy. In our case, we're going to have 3 nodes: call LLM node, execute tool call node, and send tool results node, which basically is responsible for sending the tool call results back to the LLM. Let's now start defining the edges between our nodes. So each strategy, as mentioned already, starts at node start. For that, we have an edge between node start and call LLM node. After the LLM call, 2 things can happen. LLM can either return a text message right away. This indicates that the model has reached the final answer and that it can stop executing. So for that, we need an edge from the call LLM node to node finish. But model can also return a tool call. If it returns a tool call, we need the edge between call LLM node and execute tool call node. If the model has decided to call some tool, we need an edge between an execute tool call node and send tool results node. From here, again, 2 things can happen. The model can decide not to call any more tools, so we can go straight from the send tool result node to node finish, or the model can decide to call some additional tools, and we also need an edge between a send tool result node and execute tool call. And that's it. We have created our custom strategy. If we run our agent now, and if we set this custom strategy to it, the behavior will stay exactly the same. So this is because the single run strategy the single run strategy that's being used by default works exactly the same as what we have just implemented. So if you look into the implementation of a single run strategy, you will see exactly the same implementation as what we have just did. And with that, we are approaching to the end of this talk. So in this last section, we're just briefly gonna go over things that we didn't cover, and we're gonna wrap things up with a short summary. So this is only an introduction to Koog. We only covered the basics of Koog today. However, Koog is much more powerful and it contains many more advanced features. So there's a lot more to dig into if you are interested. And to recap, we have built a simple Android weather application that has a weather agent with Koog today. In the process, we learned what agents are, how they work, how to add tools to it, and how to use strategies to control the agent behavior. So if this looked interesting to you, I really encourage you to try Koog yourself because it's free, it's open source, it's Kotlin native, and it's really easy to get started into building AI agents in Kotlin in a hands-on way. If you want to check out the full source code of the app that we have built today, you can find it at following link or by scanning the QR code. So this link will take you directly to the GitHub repository of the project that we have created today. So just a note that in order to use this project, you need 2 API keys, one for your LLM provider and one for the AkuWeather API. And that's it. Thank you all for your time and attention. And yeah, if you have any questions, you can find me after the talk. And also, if you want to chat more about Koog or anything Android related, you can find me on LinkedIn. Thank you.